Good morning, everybody, and happy December 10th. That's amazing. December's like a third over already. 2024 is going to be here very quickly. Let's find the 10th chocolate on our advent calendar, and then we can do some calculus. Let's see. There it is. It's right near the center. I'll zoom into that for you. It's right above this bear's head, right above the mistletoe. But I don't think there's going to be a bear behind this, because there never is. Let me put today's free response question on screen for you now. You'll see that today we have to deal with an unsightly table and some integrals, and I think we even get to deal with an inverse function today, so should be pretty fun. We got another one of the red chocolate balls, just like yesterday. These are super good. I assume it's, color-coded chocolate, so this will be the same chocolate product, which I consumed yesterday morning. Let's see. Oh God, it's a lot harder than the one yesterday. Still pretty good though. Old reliable. Those red Lindt chocolate truffles. All right, let's do some calculus. This is problem 3 from the 2007 AP Calc AB Exam. This is part of the calculator section, so we may need our calculator for this problem. Let's read it. The functions f and g are differentiable for all real numbers, and g is strictly increasing. So it's not just that it doesn't go down, but it only ever goes up. The table above gives values of the functions and their first derivatives. You can see some f's, some f primes, some g's, some g primes, at selected values of x, 1, 2, 3, and 4. The function h is given by h of x equals f of g of x, a composite function, minus 6. Part A is to explain why there must be a value r between 1 and 3, such that h, this function, of r equals -5. This is a fairly straightforward question. We just need to use the intermediate value theorem, or IVT. I'll leave a link in the description to my lesson on the intermediate value theorem if you need to review that. The idea, though, is that h is a continuous function. Because f and g are continuous functions, we know that because they're differentiable, and differentiability implies continuity. So f and g are continuous, the composition of continuous functions is continuous, and subtracting a constant from a continuous function, well, you'll still have a continuous function if you do that. Okay, so h is continuous, which means what we need to do is look at h of 1, because remember, we're concerned about what happens between 1 and 3. We want to show that h must equal -5 at some point between 1 and 3. So we're going to look at h of 1, and we're going to look at h of 3. If we evaluate these correctly, what we're going to see is that one of these values will be less than -5, and one will be greater than -5. So -5 is an intermediate value, which must have been taken on at some point in the interval because h is continuous. It can't just skip over something. It has to hit all of those intermediate values. So let's evaluate h of 1 and h of 3 using the definition of h and our table of values. H of 1, by definition of h, is f of g of 1 minus 6. Looking at the table, we can see that g of 1 is 2. Then we need to plug that into the function f. So we're plugging 2 into f. F of 2, we see, is 9. So this should be 9 minus 6, which is +3. And then we'll do a similar process to evaluate h of 3. By definition, h of 3 is f of g of 3. Looking at the table, we see that g of 3 is 4, and then we need to plug that into f, and we see that f of 4 is -1. Thus, this is going to be -1 minus 6. Sorry, I forgot to write the -6 a minute ago. So this is -1 and then subtract 6. That's going to be -7. And so there is our conclusion. Since h is continuous and h of 3 we found was -7 is less than -5, which is less than h of 1 we found to be 3, by the intermediate value theorem, there must exist, sorry I wrote the exists, there exists, a number r between 1 and 3 so that h of r is equal to -5. The function h must have passed -5 at some point because between 1 and 3 it is less than -5 and then it becomes greater than -5. So it must have passed -5 at some number r between 1 and 3. Moving on to part B. Explain why there must be a value c between 1 and 3 such that h prime of c equals -5. In this case, we're trying to show that the derivative takes on a certain value, so for this, we're going to use the mean value theorem. The mean value theorem tells us that since h is a differentiable function, since it's a composition of differentiable functions, whatever the average rate of change is of h on an interval, in particular, right now we're interested in the interval between 1 and 3, whatever the average rate of change of h is on that interval, the derivative must equal that average rate of change at some point in the interval. So we need to calculate the average rate of change on the interval. To find the average rate of change of a function over an interval, we just need to take the change in the function, so h of 3 minus h of 1, how much did h change from 1 to 3, and subtract by the length of the interval, so 3 minus 1. Now, h of 3 we already found is -7, so we have -7 minus h of 1 we already found that's 3. Divided by 3 minus 1 is of course a division by 2. So this is -7 minus 3, which is -10, divided by 2, which is -5. Look at that. And there is our conclusion. Since h is continuous and differentiable, we can use the mean value theorem, the MVT, which tells us since the average rate of change of h over this interval from 1 to 3 is -5, that means that there must exist a point c between 1 and 3 where the derivative of h at c is exactly -5. The instantaneous rate of change at some point must equal the average rate of change over the interval. All right, moving on to part C. Part C says let w be the function given by w of x equals the integral from 1 to g of x f of t dt. And we want to find the value of w prime of 3. So this might look kind of intimidating, but all we actually have to do here is use the fundamental theorem of calculus and the chain rule. Those things together tell us how to take the derivative of an integral function like this, which has a function in the bounds. So let's take the derivative and then we'll plug 3 into the derivative to find w prime of 3. W prime of x equals, the derivative essentially undoes the integration, but how it works is this. The upper bound needs to get plugged in, this upper bound which is a function. So it's f of g of x, but then by the chain rule we need to multiply by the derivative of that function, so we have to multiply by g prime of x. Then, to find w prime of 3, we can just plug that in and use our table. We know that g of 3 from the table is equal to, let's see here, g of 3, right there, it's 4. So this is going to be f of 4, and what is f of 4? F of 4 is -1. Okay, so this part here is -1, but remember it's also getting multiplied by g prime of 3, which from the table we see is +2. All right, so that right there is +2. So w prime of 3 is -2, their product. Remember that the lower bound of this integral would just yield a constant, which is why taking the derivative makes that part totally go away, but this function in the upper bound does have an impact on the rate of change. So that's part C. Finally, the final part is part D. If g inverse is the inverse function of g, write an equation for the line tangent to the graph of y equals g inverse of x at x equals 2. Okay, to write the equation of a tangent line, we need a couple things, right? We need a point for starters. So let's jot down our point. We're going to need a point and a slope, of course. The point has an x-coordinate of 2, so let's put that there. What is the y-coordinate? Well, we want a line that's tangent to g inverse. So the y-coordinate should be g inverse of the x-coordinate, 2. Now, if we look at our table, we see that g has an output of 2 when x equals 1. G of 1 equals 2. By definition of an inverse function, since g of 1 equals 2, that means that g inverse of 2 equals 1. So to evaluate g inverse of 2, all I had to do was look at what input makes g give an output of 2. Then I know g inverse of 2 gives an output of 1. And so that's going to be my y-coordinate. Thus, I've got my point, now I just need my slope. So I need to find the slope of g prime at this point. Alright, now to find the slope, we're going to have to take the derivative of g inverse. It'd be helpful if you knew the formula for the derivative of an inverse function, but it's not the end of the world if you don't have that memorized. We can figure it out from scratch pretty easily. By definition of an inverse function, we know that g of g inverse of x equals x, because inverse functions cancel each other out. What we're going to do next is take the derivative on the left with respect to x, and the derivative on the right with respect to x. To take the derivative on the left, we have to use the chain rule. The outside function is g, so we have to start with g prime and leave the inside function g inverse unchanged. But then we need to multiply this by the derivative of the inside function. The inside function is g inverse of x, so we have g inverse of x prime, the derivative of the inside function. On the right, the derivative of x is just 1, and then remember, we're trying to find a formula for g inverse prime, so let's solve for g inverse prime by dividing both sides by g prime of g inverse of x. Again, ideally you have this formula we're going to get memorized, but this is how you can figure it out if you don't have it memorized. Alright, there's our formula for the derivative of g inverse, so we can use that now to find the slope of g inverse at this point. Let me write this part in orange. So now we are looking for g inverse of 2 prime, right? We want the slope where x equals 2. And we know that this is equal to 1 over g prime of g inverse of 2. And let's see, what is g inverse of 2? Well, we already figured that out. G inverse of 2 is 1, because g of 1 is 2. Okay, so coming back down here, g inverse of 2 is 1. So this is going to be 1 over g prime of 1. And what is g prime of 1? Going back to the table, we see that g prime of 1 is 5. So this should be 1 over 5. I'm going to have to move everything to the left a little bit so I have room for this. This is 1 over 5. And that inverse derivative formula really comes in handy. All right, so finishing the tangent line, we have a point, 2, 1. We just figured out the slope, 1 over 5. So we can go ahead and write the equation of the tangent line using point-slope form. Y minus the y-coordinate equals the slope multiplied by x minus the x-coordinate. And there you go. That is our answer to part D. And that completes our solution to free response question 3 from the 2007 AP Calc AB Exam. Be sure to check the pinned comment or the description for a link to the PDF with all of these free response questions so you can participate in the FRQ Advent Calendar yourself and not leave me to do all the work. It's really fun to do these questions yourself. Let me know in the comments if you have any questions, and hey, if you're enjoying the free response question advent calendar, share it around with all of your fellow calculus fans. I'll see you bright and early tomorrow morning for the next episode of the Advent Calendar.